In this video, we're going to take a look at reduction reactions, specifically of aldehydes, ketones, carboxylic acids, and also something called nitrobenzene. So let's sort of start out with aldehydes, and some of the reducing agents that we can use in these particular actions are either lithium aluminum hydride, which is LiAlH4, or sodium borohydride, which is NaBH4. Now, lithium aluminum hydride works for everything. It works for aldehydes, it works for ketones, and carboxylic acids. Whereas the sodium borohydride is a little bit, I guess not as strong. It only works for aldehydes and ketones. Okay, so that's important to remember. Now with aldehydes, when aldehydes undergo reduction, they're going to produce a primary alcohol. So we can add our reducing agent here. Sometimes it's also written as just an H in square brackets, but you should put in specific catalysts here. And this is also in some methanol. So when we take, for example, ethanol and we reduce it, we would create, the number of carbons stays the same, but now instead of that double bond O, we're creating an OH, an H, and an H. So the primary alcohol, ethanol. If you wanted to balance this, you could put in a 2H plus or plus 2H as a reactant, and that would create a balanced chemical reaction. But most of the time we kind of leave this out because we don't really need to show it, but to know that it's there if you do need to balance. Now ketones, when ketones undergo reduction with a reducing agent in methanol, they're going to produce a secondary alcohol. So in this particular example with propanone, where the double bond O is, we're going to create an OH and an H, and then create another, well, we're not creating another CH3 here, that one's there. So again, if you wanted to balance it, you can add in the 2H there, and that is creating our secondary alcohol here, which is propan 2-ol. Carboxylic acids, when they undergo reduction, they do require a stronger reducing agent. So the lithium aluminum hydride is the only one that works for this particular reaction. It has to happen in a ether called ethoxyethane, and it actually happens in 2 steps too. So you need step 1 is that, and then step 2, you're in an acidic kind of aqueous environment, and that's going to create a primary alcohol. So with this particular reaction here, we're going to create a primary alcohol here, like so. So this particular one, we're creating ethanol as our major product. This one's a little funkier to balance, but if you wanted to write it balanced, you'd have 4H as another reactant, and then your other product would be water. But again, usually we don't end up showing these just because it's not really that important to the particular reaction. Okay, so those are our major redox reactions with the aldehydes, the ketones, and carboxylic acids. Essentially, they are the opposite to the mild oxidation reactions. The other reaction we do need to look at here is the reduction of nitrobenzene, which is going to produce something called phenylamine. And so phenylamine is an amine group on a benzene ring. This particular reaction happens in 2 steps. We've seen this nitrobenzene before because you can make it through a substitution reaction with nitric acid as well as sulfuric acid and reacting that with benzene, and that's going to create your nitrobenzene. So then we can take our nitrobenzene now and reduce it to create this phenylamine. This happens in 2 steps. So the first step requires this catalyst of a tin concentrated hydrochloric acid and some heat. The first step can be written like so. So this is our nitrobenzene in an acidic environment. So that's where the HCl is coming from. And our reducing agent, which is our tin in this case. And that's going to create we would call this the protonated form. Protonated. I can't spell. That's okay. So this is our protonated form of phenylamine. It's protonated because it has an extra positive charge and 1 extra hydrogen than our final product. So that's our first step. And then our second step happens in a basic environment. So sodium hydroxide will react with this protonated form of the phenylamine to create our final product and water. So you should be able to write it out in both this form as well as both of the reactions separately here. So those are our reduction reactions that happen in organic chemistry. That's it for this video. We'll see you in the next one.